Introduction to Econometrics. This is the first video on econometrics. First we'll go about definition of econometrics. The literal definition of econometrics is measurement in economics. Econometrics is made up from economics plus metrics. Metrics means measurement, hence econometrics is measurement in economics. There are definitions given by authors. The first one is the method of econometric research aims essentially at a conjunction of economic theory and actual measurements using the theory and techniques of statistical inference. This definition was given by Habermas in 1944. The second definition is econometrics may be defined as quantitative analysis of actual economic phenomena based on the concurrent development of theory and observation reflected by appropriate methods of inference. This definition was given by Samuelson, Koopmans and Stone in 1954. From this definition, we are clear that econometrics is actually the combination of statistical theory and economic theory. Means we use different kind of statistical techniques on the economic theory. Methodology in econometrics. The first step is the statement of economic theory or formation of hypothesis. It is that aspect of economic theory which is to be tested for empirical validity. Suppose we want to examine validity of the Keynesian consumption theory that postulates the consumption is a function of income. Here the hypothesis would be the consumption is a function of income. The second step is specification of economic model to test the theory or hypothesis. This is the model specification. The model is an algebraic representation of real-world process. At the stage of model specification, we decide on the precise form of functional relationship between consumption and income on the model of Keynesian consumption theory. The model for Keynesian consumption would be like this: yi equals to alpha plus beta plus xi, where y would be the consumption, x would be the income, and I denote the particular individual. However, the reality is that the relationship between consumption and income is not exact, but a typical one. This becomes clear when we look at the data, which shows that for each value of income or x, there is a whole distribution of values of y. Hence, the model will be yi equals to alpha plus beta xi plus epsilon I. Here epsilon I is the stochastic term or disturbance term or error or residual. This equation represents an econometric specification or model specification of consumption-income relationship. The third step is estimation. Our objective in this step is to obtain the estimates or numerical values of the unknown parameter. Some popular estimation techniques are OLS, ordinary least square, MLE, maximum likelihood estimation, and method of moments. The fourth step is verification or inference. In this stage, we develop suitable criteria to examine whether the estimates obtained are in conformity with the expectation of theory that is being tested. The fifth stage or last step is forecasting and policy formulation. This is the final stage where we utilize the estimated model for the purpose of forecasting and policy formulation. In the Keynesian consumption theory, we specified the model as yi equals to alpha plus beta xi plus epsilon I, where alpha and beta are the parameters of model. So these parameters are to be estimated, and for this estimation following assumptions are made. The first one is the mean or expected value of disturbance term epsilon I is 0. The second one is the disturbances have uniform variances, which is known as the assumption of homoscedasticity. Here the disturbances term are supposed to have the equal variance or constant variance, which is sigma square. If there is no equal variance in the disturbance term, then this is the problem of heteroscedasticity. The third assumption is the disturbances are uncorrelated, which is known as the assumption of serial independence or non-autocorrelation. Here the disturbances are uncorrelated. If disturbances term are correlated with some degree of correlation, then we face the problem of autocorrelation. The non-autocorrelation means error terms should be normally distributed. If they are not normally distributed, then we face autocorrelation. The fourth estimation is error term is normally distributed. This assumption is necessary for conducting statistical test of significance of the parameters estimated, which is t-test. The fifth assumption is x, which is explanatory variable, is a non-stochastic variable with fixed values in repeated samples. While doing econometric analysis, we faces the different types of data, or we need these data. There are several types, but we will deal about the three types of data. First one is cross-sectional data. The data collected for different entities in a single period of time. There are data obtained by conducting a survey only once. Thus, cross-sectional data set may consist of a sample of individuals, households, firms, regions, countries, or any other type of units as a specific time point. The second type of data is time series data. Time series data, also called macro data, are those data collected for the same entity for different time periods. Thus, a time series data set consists of observation on one or more variable over time. Time series data examples are GDP, money supply, private consumption, import, export, remittance, etc. The third type of data we face is panel data, which is the combination of cross-sectional data and time series data. Panel data are also called longitudinal data. These are data collected for multiple entities where each entry is observed in two or more time points. Repeating cross-sectional study at least twice in same area, same household, and using same questionnaire, we get the panel data. Thank you for watching this video. In the next video, we'll discuss about the simple regression linear model, SLRM, and don't forget to subscribe and share to your friends.